This lesson is kind of a continuation of lesson 9, just the previous lesson, in that we're going to just take a bunch of data files and do some calculations on them, the same exact calculation, linear regression. It's slightly different than the last one. In the last one, we were able to just use construction of a character array, concatenation of a character array just by putting strings together to make the right file name structure, and then put that into a loop. In general, it's a good idea to organize your data and organize your files so that you can do that kind of thing. You know what the data file structure is going to be and all that stuff. That's a very good organizational tool to have, but it doesn't always happen that way. So I want to teach a different way to get the list of data files in a folder. And so that's what I'm going to talk about in this lesson. We're going to start with load calib 2 as our starting point. And so I find that folder, I make a copy of that folder, I change it to load calib 3, and then I go into that folder. Notice that calib_data is still there, and linreg is still there, and so I'm just going to change load calib 2_2 to be load calib_3.m. So I'm just changing the m file name, and I'm ready to go. I go into Octave and I make sure that I'm in the right folder, the folder load calib 3. Now I want to learn about a couple of new commands. The first one is dir. If you've had me in other lesson series, you know all about the command prompt and a lot of command prompt commands, DOS commands for old people. And dir is one of them. Tell me what's inside. So if I do a dir at the command window, it will work. So that's pretty interesting. A lot of DOS commands work at the command window for MATLAB. In the olden days, it was all just a command window. MATLAB was just a specialized command window that had a slightly different command prompt, a little double greater than symbols instead of the regular prompt, right? If you're old enough to remember that, like me. Anyway, so dir is a command, and it gives you the contents of what's inside your directory. Here we see it says there are 5 things. There's calib_data, that's a folder. There's load calib_3, that's an M file, and linreg.m, that's an M file. Then there's 2 other ones. There's dot and there's dot dot. Dot and dot dot are files inside every directory that gets made, and they all have the same meaning in all operating systems: DOS, Mac OS, and Linux. And dot means the current directory you're in, and dot dot means the parent directory or the parent folder. So if you cd space dot dot, if you change directory to dot dot at the command prompt, it'll go back up one directory. That's what dot dot does. And it's a file that's always in every folder. If you make a folder the normal way, it's going to have those 2 files in there. There's another command. It's called ls. ls is for Mac OS and Linux, not DOS. ls doesn't work in DOS on Windows, but it does work for all Unix and Linux-based operating systems. So ls, if I do ls instead, list the contents of the directory, it just gives the 3 file, the folder and the 2 files. It doesn't give dot and dot dot. ls in MATLAB and Octave don't give you all those files. MATLAB is a little bit different. MATLAB's ls is not quite as well behaved, so just if you do ls and you get a bunch of other files, just recognize that MATLAB's ls is not as good as Octave's ls, so that's just a little asterisk at the beginning here. You can actually, dir and ls are functions, right? So you can assign the output of dir or ls to a variable. So let's say a equals dir, right? Well, look at that. Wow, it's a structure. It's this weird structure that has all sorts of, it's something weird, right? Well, it turns out that each element of a directory has a lot of details. Name, size, date, all sorts of stuff in there that the operating system uses to know what's what in the directory system that it's running. So dir returns a structure, a complicated structure. It's going to have 5 elements to it. There are 5 components, and each of those components has details, has aspects to them, its name, its size, and so forth. So it's a complicated structure. ls doesn't do that. So if you say b equals ls, b just returns a character matrix. And it's the size of the rows are each row is each file of the 3 files. And again, in Windows, in MATLAB, it's going to give you it's going to give you more. It's going to give you a bunch of old things and stuff in there. So just watch out. Note that it looks a little different in DOS, in MATLAB for Windows. Okay. So, so if I'm going to just try to get the file name out of it, I think I'm going to use ls, not dir, because all I need is a file name. I don't need size and all that other stuff, right? I'm just trying to get the file names of everything in a folder, right? You can get the name of something from the A structure that we have. So if I look at A sub 3, that's going to be not dot, it's going to be the calib data folder, right? So you look at it, and I say I just say A parentheses 3, the third element of this structure A, and it shows all the details of the third element. Its name is calib data, its path, its date, how many bytes, all that stuff. Good? All right. So so if I want to just extract just the name of it, right, I can say a3.name. The structure is the origins of kind of the beginnings of object-oriented programming. These structures are kind of like the antecedent to objects in object-oriented programming. So dot, then whatever feature you need is the syntax of a lot of object-oriented programming. MATLAB and Octave do have object-oriented programming capabilities, and you can make a GUI and all sorts of stuff with MATLAB and Octave. You can get really sophisticated in your programming techniques. Good? So you can get it, but using ls is way easier. So I'm going to use ls in my script. Good? So I edit load_calib underscore 3.m. That comes up. I want to go back to the command window and test out the way I'm going to make the program. The program I'm going to try to do is going to just read the contents of a directory and do all the calculation on all the data files that are in that directory. That's what I'm going to do. Good? That's what this script load_calib underscore 3 is going to do. But before, I'm going to go back to the command window real quick. I'm going to go back to that tab, and I'm just going to say, I'm going to clear all. I'm going to clear out A and B so I don't have those in words, and I'm going to say A equals ls, and then I'm going to give it the folder. What's in the folder? Calib underscore data, right? So what's in that folder? And it returns the 10 data file names. Nice. That's pretty cool. Wow. So I'm going to use that in my script. In my script, I'm going to make a variable called cdir, calib directory, right? cdir equals ls calib data, in quotes, semicolon, so I don't want it to spit out the answer. Then, when I go into, then I'm going to make a loop that's going to go 10 times. So I know there's 10 files, so it's going to go through 10 times. And so if you look at the first line in that loop, I'm going to do string concatenation again, right? So I have the first part of the string is just going to be the path, calib data /. Then the second part of the string is just the ith row of that matrix structure, cdir, I comma colon, right? So all characters in the ith row. That's how that reads. And again, there's no space, when fname is not going to have a space between the two, when you give it two strings with separated by square brackets, it just concatenates it all and makes it all one big long string. That's how square brackets work with strings. I didn't say that in the last video, but it was implied, and so I just wanted to make explicit that you know that. Then the normal thing, I just load the data file, X and Y, I get the linear regression, and it works, no problem. I'm going to make the out variable just like I did before in lesson 9, and let's run it. So I compile it, I save it, I save it, I go back to the prompt, and I run it, and out comes out, and you can see that it looks just like the end of last lesson. Klugey, all exponential formats, but still, it's there. Wow. Right? So now I can just go in, I don't need to know the context of the names of all the files. I can just go grab them all, if it's in a directory, and just use them all in this way. The next thing I want to do is I want to make the output pretty, right? And when I save save it to a file or something like that. I don't want all these exponential formats. So in order to do that, there's all sorts of ways that you can do that, but the main way to do that is with the fprintf command. So this is another C-like function in MATLAB and Octave that you can do format specifications using the fprintf command. So I open a file as a write using FID. I'm going to call it calib.txt. Then I do a for loop 10. I know there's 10 rows in my out matrix. And so then I'm just going to print. I'm going to print a %d, and then I'm going to separate them all by tabs. And I put a little extra space after the d, so because 1 versus 10, I wanted to make it all look pretty. So that's that. There's a couple of spaces, and then a tab, and then the 3% f's slope intercept r squared. Good. Right, and so then I close the file. Good, so now I'm gonna run that. I save it, and then I go back and I run that, and I look, and then I go to the file browser on the left there, and I double click on calib.txt. It comes up in my Octave editor. I think that's gonna happen in MATLAB too, it just depends. But normally, if you call it from your file browser, from MATLAB or Octave, it's probably going to come up in MATLAB, in the MATLAB editor. So that's the normal case, but I'm not always sure. So anyway, and calib.txt comes up in my Octave browser, and you can see that it's nice and pretty now. Now the columns and all that stuff are nice, and it's all organized. Pretty cool, yeah. If you're following along in MATLAB, you're saying, Olson, I can't do this because, hey, Dr. Olson, I can't do this because I got all these extraneous files in there. It's not all files. My C directory has more than 10 rows. It's got a bunch of different other files. This happened to me on my MATLAB thing when I was testing this out, and so it probably happened to you as well. So you're mad right now. Don't be mad. I'm going to walk you through how to fix this, right? So this is just for Octave. So the Octave's ls appears to be better behaved than MATLAB's ls. It doesn't give extraneous files. I think it gives all sorts of backup files in MATLAB or something. I don't know. Anyway, so what I did was I staged having other files, not just the data files in there, but if you have other files in your directory as well, or if the ls command gives things other than just the 10 data files. So I added 3 data files in there. I added one annoying file, then I added another annoying file, and then at the bottom I added a readme file, because you might see all that stuff. This happens all the time, even though in my opinion it's bad organizational structure. You should have a data file, you should have a directory that only has data in it, nothing else. And so it's good organization to not do this, but it happens, and so people have all sorts of, describer data in there. There could be all sorts of extraneous files. There might be extraneous files in there. And so it's not uncommon for directories to do this. And for people who are doing the MATLAB version of ls, this might happen anyway. They might have certain dot and dot dot might show up, that kind of thing. Okay. All right. So I've made it. And then if you look, I'm going to, at the command window, I'm going to do an ls of calib data now. And you can see that there's 13 rows, not 10. There's more than 10 rows, right? And 10 of them are there, and then there's all these other files. So let's start with that and see if I can get just the data files out of that ls function call. Good? So here's the script that will do that. The first thing I do is I'm going to do the same cdir equals ls command. Then I want to find out how many files did it find, how many rows there are. So ROWS is a MATLAB command, COLS, columns, is a MATLAB command. You can find out the size of a matrix. Length is the larger of the two. So if rows are bigger than columns, it'll give you rows. If columns are bigger than rows, it'll give you columns. So length is another one that we know, but rows is explicit. It's going to tell me how many files are there that came out from CDIR. So N is the number of files total in that directory. I'm going to make a new index. I'm going to have an index for going through all the files, and I'm going to have an index for just going through the data files, right? So I is going to go from 0 to n, from 1 to n, and j is going to start at 1. And j is going to start at 1. So that's how this for loop is going to get set up. And I looked at the output of CDIR, and I noticed that the first character of all the data files are D, and the first character of everything else isn't D. I made it that way so that it's nice and easy, but a lot of times it's just that simple. You can have you'll have some if statement, some condition where the data files look a certain way and all the other files don't look a certain way. They have the same extension and all the other ones don't have that extension. There's all sorts of possibilities there, right? And in the case of probably if you're a MATLAB user, all the files that come up don't have a D as their first letter, right? So this will probably work for you as well. But just be creative in the if statement, how do I differentiate between the files that are data files and the files that aren't in an if statement? That's what this script is about. So I just checked and said, is the first character of that, is the first character of the row, the ith row of this results of the ls command, does it start with a D or not? If it starts with a D, I know it's a file. So then I do all the file stuff. I calculate slope, intercept, and r squared, and then I increment j. I found one of the data files, I'm going to increment j. So after that whole loop there, j is going to end up as 11 because it's going to go through 10 data files and then increment right after that. And n is going to go all the way through 13, right? That's how that's going to work. I want to know how many points that slope, intercept, and r squared have. So that's j minus 1, 10. So number of points is going to be j minus 1, and then I do the for loop I to 1 to n points, and when I'm doing the fprintf statement. So those are the main differences in this script over the other one. So the only structural difference is that I'm checking each file name that's inside this directory, inside this folder, calib data, and saying, is it a data file or not? Does it start with D or not? Good? All right, so I save that and I run it with this with all the extraneous data files, and it works as well. So that's a strategy for if you have a folder that has a lot of different files in it, and the data files in it, you can just parse out the files you want with clever if statements, highlighting the differences between data files and other files in that folder.